Here we have to integrate x plus 2 upon under root of x square minus 1. Just split the terms. So you'll get x upon under root of x square minus 1 plus 2 upon under root of x square minus 1. Right? Now, let's say your first term is I1 and second term is I2. Let's integrate separately. Our I1 is simply integration of x upon under root of x square minus 1. So here we just have to assume x square minus 1 is equal to t. Differentiate both the sides, we will get 2x dx is equal to dt. So we can say this x dx will be dt by 2. So let's modify our integration. This x dot dx will become dt by 2 integration of 1 upon under root of t. So we don't have to worry about this 1 by 2. We just have to integrate t raised to minus 1 by 2. So integration of t raised to minus 1 by 2 will be t raised to 1 by 2 upon 1 by 2 plus c. So here 2 will cancel out. We will get under root of t, or we can say under root of x square minus 1. And now what about I2? I2 is simply integration of 2 upon under root of x square minus 1, where we can take 2 outside and we just have to integrate 1 upon under root of x square minus 1 dot dx. And for that, we are going to use fifth formula. So it will be 2 times log mod x plus under root of j y plus c, right? For final answer, we need to find I, which is I1 plus I2. So first of all, let's get our I1 plus your I2, and this is your C1 and C2. So plus C, where C is C1 plus C2. So tada, this is your final answer. Here we have to integrate x minus 1 upon under root of x square minus 1. So let's split our numerator x minus 1 and give individual denominator. Let's say your first term is I1 and second term is I2. So let's try to integrate one by one. Initially, let's try to integrate our I1. And for that, we have to integrate x square minus 1 is equal to t. So differentiate both the sides, we will get 2x dx is equal to dt. Or we can say x dx will be dt by 2. So let's modify our I1. This x dot dx will become dt by 2. And 1 upon under root of x square minus 1 will be t. So we don't have to worry about this 1 by 2. We just have to integrate t raised to minus 1 by 2, which is nothing but t raised to 1 by 2 upon 1 by 2 plus c1. Now for simplification, 2 will cancel out. We will get t raised to 1 by 2. Just substitute the value of t, which is x square minus 1, or we can say under root of x square minus 1 plus c1 is your I1. Now let's move to the your I2, which is integration of 1 upon under root of x square minus 1. So to integrate 1 upon under root of x square minus 1, we are going to use fifth formula. So it gives us log mod x plus j y, or we can say under root of x square minus 1 plus c2. Okay. So to get the final answer, just substitute the value of I1 and I2. So your first term is under root of x square minus 1 plus मेहनत कर लें, फायदे उठाइए। log mod x plus under root of x square minus 1 plus c, where c is c1 plus c2. So ta-da! This is your final answer. Here we have to integrate 5x minus 2 upon 3x square plus 2x plus 1, which is in the form of ax plus b upon ax square plus bx plus c. So let's follow its steps. Our first step is get the numerator in terms of differentiation of denominator. So for that, we have to write down pi x minus 2 is equal to, so m into differentiation of your numerator, which is 3x square plus 2x plus 1 plus n, or we can say 6x plus 2. Okay, now let's simplify. Right hand side, m multiplied with 6x will give us 6mx, and m multiplied with 2 will give us 2m, plus n remain as it is. On left hand side we have pi x minus 2. Now if we compare the coefficient of x, we will get pi is equal to 6m, will give us m is equal to pi by 6. And if we compare the constant terms on both sides, we will get minus 2 is equal to 2m plus n. So we can say n is equal to minus 2 minus 2m, or we can say pi by 6 minus 11 by 3, right? Now let's separate our numerator using equation number 1. So let's get our first equation and give individual denominator dot dx and integration dot dx. Let's say your first term is I1 and second term will be I2. So let's try to integrate our this I1. Substitute the value of m, which is pi by 6. Now to integrate I1, we have to assume 3x square plus 2x plus 1 is equal to t. So we will get 6x plus 2 dot dx is equal to dt. So if we modify our I1, this pi by 6 will be remain as it is. Integration of this 6x plus 2 dot dx will become your dt, and 1 upon 3x square plus 2x plus 1 will be your t. So pi by 6 integration of 1 upon t is simply log mod t plus c1, or if we substitute the value of t, we will get pi by 6 log mod 3x square plus 2x plus 1 plus c1. Okay, now let's try to integrate our second term, which is our I2. Here your n is constant and having the value of minus 11 by 3. So we don't have to worry about it. We just have to integrate 1 upon 3x square plus 2x plus 1, which is in the form of ax square plus bx plus c. So we have to follow its steps. To get last term, we need coefficient of x square, which is 3, coefficient of x, which is 2. Then we can say our required last term will be b square upon 4a, or we can say 4 upon 4 times 3, which will give us 1 by 3. Okay, now let's write down what we have. Now let's add and remove our required last term, which is 1 by 3. So here we can say in denominator, your first 3 terms will create the perfect square. of root 3x plus 1 upon root 3 and minus 1 by 3 plus 1 will be plus 2 by 3 dot dx, which is in the form of 1 upon x square plus a square, where your x is root 3x plus 1 upon root 3 and your a is under root of 2 by 3. So we are going to use third formula. So its integration will be 1 upon a, or we can say under root of 2 by 3 tan inverse of x by a, or we can say root 3x plus 1 upon root 3 upon root 2 by 3 into, we have to divide the coefficient of x, which is 1 upon root 3 plus c2. Now let's simplify. This root 3 will cancel out. We will get minus 11 by 3 root 2 and tan inverse of, if we take the LCM of root 3, we will get 3x plus 1 upon root 2 plus c2 is your final I2. Now to get the final answer, we just have to take summation of I1 and I2. So first of all, let's get our I1 plus your I2, which is minus 11 by 3 root 2 tan inverse of 3x plus 1 plus c, where c is c1 plus c2. So tada, this is your final answer. Here we have to integrate 6x plus 7 upon under root of x minus 5 into x minus 7, or we can say we have to integrate 6x plus 7 upon x square minus 12x plus 35 dot dx, which is in the form of ax plus b upon ax square plus bx plus c. Okay, now let's take first step, in which we have to assume 6x plus 7 is equal to m into differentiation of your denominator, which is 2x minus 12 plus n. Now let's simplify our right hand side. M multiplied with 2x will give us 2mx. M multiplied with 12 will give us minus 12m plus n. But on the left hand side we have 6x plus 7. So if we compare the coefficient of x, we will get 6 is equal to 2m, or we can say m is equal to 3. Right. And by comparing constant terms on the both sides, we will get 7 is equal to minus 12m plus n, or we can say n is equal to 7 plus 12m, which will give us 43. So we complete the first step. Now in second step, we have to split our numerator using your first equation. So let's get our first equation and give individual denominator. Okay, now let's try to integrate separately. First term is I1 and second term is I2. So first of all, let's try to integrate I1. Now here the value of m is 3, and to integrate this term, we have to assume our denominator is equal to t, or we can say x square minus 12x plus 35 is equal to t. So if we differentiate both the sides, we will get 2x minus 12 dot dx is equal to dt. We don't have to worry about this 3. It's a constant. Let's modify our I1. This 12x minus 12 dot dx will become dt, and 1 upon under root of x square minus 12x plus 35 will become under root of t, or we can say we have to integrate t raised to minus 1 by 2, which is t raised to 1 by 2 upon 1 by 2 plus c2, or we can say we will get 6 times under root of t, which is x square minus 12x plus 35 plus c2 is your I1. Now it's time to integrate our I2. Here the value of n is 43. We don't have to worry about it. Our I2 is in the form of integration of 1 upon ax square plus bx plus c. So we have to follow its steps. Its first step is add and remove last term. And to get the last term, we are going to need coefficient of x square, which is 1, coefficient of x, which is minus 12, will give us our last term is equal to b square upon 4a. You can say 144 upon 4 times 1 will give us 36. So let's write down what we have. 43 outside integration of 1 upon under root of x square minus 12x, and then finally 35. Now let's add and remove our required last term, which is 36. So here this 43 remain as it is. In denominator, our first 3 terms will create the perfect square of x minus 6 and minus 36 plus 35 minus 1. Finally, here we have to integrate 1 upon under root of x minus 6 the whole square minus 1, which is actually in the form of 1 upon under root of x square minus a square, where your x is simply x minus 6 and a is simply 1. So its integration will be log mod x, which is x minus 6, plus under root of j hoy, or we can say x minus 6 the whole square minus 1 plus c2. Now for final answer I, which is equal to I1 plus I2. So let's get our I1 in first term plus your I2 will be second term plus C, where C is C1 plus C2. So, ta-da! This is your final answer. Here we have to integrate x plus 2 upon under root of 4x minus x square, which is in the form of ax plus b upon ax square plus bx plus c. So let's follow the steps. Our first step is we have to set the differentiation of denominator in terms of numerator. So let's take x plus 2 is equal to m times differentiation of 4x minus x square, or we can say minus 2x plus 4 plus n. Now let's simplify the first term. M multiplied with minus 2x will give us minus 2mx, and m multiplied with 4 will give us plus 4m. plus n will be as it is. On left hand side we have x plus 2. Now let's compare the coefficient of x. On left hand side we have 1 as a coefficient of x, and on right hand side we have minus 2m. So here we'll get m is equal to minus 1 by 2. Now let's compare the constant terms. So we will get 2 is equal to 4m plus n, or we can say n is equal to 2 minus 4m. Let's substitute the value of m, which is minus 1 by 2. So we will get n is equal to 4. So here we complete our first step. Now in second step, we have to separate our numerator using first equation. So let's get our first equation and give individual denominator and give individual integration. Now in third step, let's assume first term as a I1 and second term as a I2. So first of all, let's try to get our I1. Now let's substitute the value of m, which is minus 1 by 2. And to integrate I1, we have to assume 4x minus x square is equal to t. So let's differentiate both the sides. 4 minus 2x dot dx is equal to dt. So our I1 will be modified as this minus 1 by 2 as it is, integration 2x plus 4 dot dx will become dt, and 1 upon under root of 4x minus x square will be your t. So here we just have to integrate 1 upon root t, or we can say t raised to minus 1 by 2, which is simply t raised to 1 by 2 upon 1 by 2 plus c1, or we can simplify this 1 by 2 cancel, minus of under root of t, or we can say 4x minus x square plus c1 is your I1. Now let's move to the integration of our I2. First of all, let's substitute the value of n, which is 4. And our I2 is in the form of 1 upon under root of 4x minus x square. And to integrate this term, we have to add and remove the last term. Let's get our last term using coefficient of x square, which is minus 1, and coefficient of x, which is 4. So here we'll get our last term is equal to b square upon 4a, or we can say 16 upon 4 minus 1 will give us minus 4. So let's write down what we have. So let's add and remove the required last term. So here 4 is to be given as it is, 1 upon under root of this plus 4 will be as it is. After taking minus common, the last three terms will create the perfect square of x minus 2. So here we just have to integrate 1 upon under root of a square minus x square. Your x is simply x minus 2 and a is 2. So its integration will be sine inverse of x, or we can say x minus 2 upon a. which is 2, plus c. Now let's get our final answer I, which is I1 plus I2. So our first term is minus under root of 4x minus x squared plus your I2, which is 4 sine inverse x minus 2 by 2 plus c, where c is c1 plus c2. Ta-da! This is your final answer. Here we have to integrate x plus 2 upon under root of x square plus 2x plus 3, which is in the form of ax plus b upon ax square plus bx plus c. So in first step, we have to set the differentiation of denominator in the numerator. So we have to assume x plus 2 is equal to m times differentiation of x square plus 2x plus 3, or we can say 2x plus 2 plus n. Now let's simplify first term. M into 2x will give us 2mx, and m will multiply with 2 will give us 2m plus n remain as it is. On left side we have x plus 2. Now let's compare the coefficient of x. On left side we have 1 as a coefficient of x. So let's compare 1 with 2m. Will give us 1 is equal to 2m. So here we'll get m is equal to 1 by 2. And by comparing the constant terms, we will get 2 is equal to 2m plus n. Or we can say m is equal to 2 minus 2m. And our m is 1 by 2. So our n will be 1. So here we complete our first step. Now in second step, we have to separate the numerator of I using first equation. So let's get our first equation and give individual denominator. Now let's consider first term as a I1 and second term as a I2. So let's try to integrate one by one. First of all, let's get our I1. Here, substitute the value of m, which is 1 by 2, which is constant. We don't have to worry. And to integrate I1, we have to assume x squared plus 2x plus 3 is equal to t. So we will get 2x plus 2 dot dx is equal to dt. So this 1 by 2 is constant, take it outside, and this 2x plus 2 dot dx will become dt, and 1 upon under root of x square plus 2x plus 3 will be your t. So here we just have to integrate 1 upon root t, or we can say t raised to minus 1 by 2. So here 1 by 2 is as it is. Integration of t raised to 1 by 2 is simply t raised to 1 by 2 upon 1 by 2 plus c1. So here 1 by 2 will cancel out. Under root of t, or we can say under root of x square plus 2x plus 3 plus c1 is your I1. Now let's try to integrate our I2. IQ. Sapas. Now here n is 1, and our I2 is actually in the form of 1 upon under root of x square plus 2x plus 3. And to integrate this term, we need to get the required last term. So let's get the coefficient of x square, which is 1, coefficient of x, which is 2. So we can get our last term, using b square upon 4a. 4 upon 4 times 1 will give us 1 as a required last term. So let's write down what we have. Now let's add and remove our required last term. So here our denominator can be simplified as these first three terms will create the perfect square of x plus 1, and this minus 1 plus 3 will become plus 2. So here we just have to integrate 1 upon under root of x plus 1 the whole square plus 2, which is actually form of 1 upon under root of x square plus a square, where your x is x plus 1 and your a is root 2. So its integration will be log mod x, you can say x plus 1 plus under root of jy plus c2, or we can say log mod x plus 1 plus under root of x square plus 2x plus 3 plus c2. So we are ready to get our final answer. I is equal to I1 plus I2. Your first term is your I1 plus your second term will be I2 plus C, where C is C1 plus C2. Ta-da! Here we have to integrate 5x plus 3 upon under root of x square plus 4x plus 10, which is in the form of ax plus b upon ax square plus bx plus c. So let's start from the first step. We need to get differentiation of denominator in terms of numerator. So we have to assume 5x plus 3 is equal to m times differentiation of x square plus 4x plus 10, or we can say 2x plus 4 plus n. Now let's simplify. M multiplied with 2x will give us 2mx. M into 4 will give us 4m plus n will be as it is. But on the left side, we have 5x plus 3. So if we compare the coefficient of x, we will get pi is equal to 2m, or we can say n is equal to pi by 2. Now let's compare the constant terms. So we'll get 3 is equal to 4m plus n, or we can say n is 3 minus 4m, where m is pi by 2 minus 7. Here we complete our first step. Now in second step, we will separate our numerator using first equation. So let's get our first equation and give individual denominator. Now substitute the value of m, which is pi by 2, and the value of n, which is minus 7. We have to consider first term as a I1 and second term as a I2. So first of all, let's try to integrate I1. And to integrate I1, we have to assume x square plus 4x plus 10 is equal to t. So we will get 2x plus 4 dx is equal to dt. So I1 will be modified as pi by 2 will be given as it is, integration. This 2x plus 4 dot dx will become dt, and 1 upon under root of x square plus 4x plus 10 will be t. So we just have to integrate 1 upon root t, or we can say t raised to minus 1 by 2, which can be easily done as t raised to 1 by 2 upon 1 by 2 plus c2. So here 2 will cancel out. We will get pi times under root of t, or we can say x square plus 4x plus 10, or we can say c1. Okay. Now let's move to the integration of I2, which is minus 7 upon under root of x square plus 4x plus 10, which is actually in the form of 1 upon under root of ax square plus bx plus c. So to integrate it, we have to add and remove the last term. So let's use the coefficient of x square, which is 1, and coefficient of x, which is 4. So we can get our last term using b square upon 4a. So we will get 16 upon 4 times 1, or we will get 4 as a last term. So let's write down what we have. Now let's add and remove our required last term. Our denominator will be simplified as 1 upon under root of this first 3 terms, create perfect square of x plus 2, and this minus 4 plus 10 will give us plus 6. Here we have to integrate 1 upon under root of x plus 2 the whole square plus 6, which is actually in the form of 1 upon under root of x square plus a square, where your x is x plus 2 and your a is root 6. So its integration will be log mod x plus under root of j y, which is x plus 2 the whole square plus 6 plus c2, or we can get minus 7 of log mod x plus 2 plus under root of x square plus 4x plus 10 plus c2. So we are ready to get our I, which is I1 plus I2. Our first term is your I1 plus our second term is minus 7 log mod x plus 2 plus under root of x 4x plus 10 plus c. Let's see, c1 plus c2. Ta-da! This is your final answer.